Okay, so I'm gonna start doing counting proofs, and not proofs, sorry, let me correct myself. I'm going to do counting problems. Why am I not doing counting proofs? Well, first of all, I'm currently taking a discrete math course. That's why I'm doing these videos. It's for practice and to hopefully help others. And in my class, we didn't do proofs really with counting. We did not really given worksheets, and we're not really being tested on proofs, on counting proofs. And counting's really difficult in math. So that's why I'm doing counting problems. What do I mean by counting problems? Simply problems that are like, how many digits that have this condition are there? How many subsets of this set are there? It's basically asking how many of X is there? How many of X given this is there? And I don't like the way it was taught. The way it was taught was just multiple examples from concepts we've seen before. Instead, I'm gonna break it down into segments, and then at the end, maybe I'll start merging or doing like flipping between. So first, I'm probably just going to do a bunch of counting problems to do with subsets. So if I give you like a subset A that has like 1, 2, 3, and B, and then I ask you, okay, like how many subsets of A are there that have like size 2 with B, right? And then after doing like maybe 10, 20, however many I feel comfortable doing, I'll then maybe move on to digits. So this is when it's like how many four-digit numbers are there that are even? How many four-digit numbers are there that have at least 2 twos? Questions like that. After doing subsets and digits, I'm probably going to do words. This is going to be probably a shorter list, I'm hoping. This is going to be like, if I give you a word, how many different combinations of this word are there? How many different rearrangements where these two letters aren't together are there? Things like that. And I think then I'll start doing like, I'll call them real world counting problems. Like if you have 10 10-cent coins, 1 loonie, 1 toonie, I'm very Canadian, or if you have 2 dimes and 4 quarters, how many different combinations can you get of these coins to get a total number? Or like if you have this many balls in a jar of blue and red and you need to pick 5, like things like that. Those will be real world problems I'll do later. But that's how I'm going to approach counting, is I'm just going to focus on problems and figuring out how you need to approach a problem, the notation we need to get used to, because the notation I'm struggling with right now is the choose notation, N choose K. Like, when do I use this notation? How do I use this? Permutation type notation, like 3 factorials, or just factorials in general. This is like, I know this is to do with subsets or power sets. So like this would be the total number of subsets of something. So the total number of subsets of A would be 2 to the power of 4, because there's 4 elements here. And then the other notation I'm struggling with would be something like a mixture of these, like n times k times 3, for example. Like, when would I need to use that? And then there's, of course, like the simple just multiplication, like, type answers. So I'm just making this right now so I explain what this playlist is really going to try to be. It's going to be me trying to solve problems and trying to really just get comfortable with knowing when to use each one, what each one really means, what kind of counting should you expect to have to do with this, these types of problems, these types of problems, these types of problems, and these types of problems. I don't really see how you would mix these problems. Maybe there's a way to interpret a problem in a different way, but from my understanding is they're pretty concretely divided. There's no real intersection, at least not at my surface level course. So yeah, we're gonna give this a shot and really see how it goes. I have a quiz tomorrow on this, so I'm gonna try and just pump out as many videos as I can on this subject to hopefully get as much practice as possible in beforehand.